So today I will explain how the SAP-1 or the simple as possible one computer calculates the result of the 4 plus 12 minus 5. So I'll describe here the program and its steps, the function of each part of the SAP-1 circuit, and how the SAP-1 processes instructions step by step. So let's begin. So for the step 1, the SAP-1 circuit overview. So the program counter. So the SAP-1 circuit consists of the following components. The program counter. So the PC keeps track of the memory address of the current instruction. After each instruction, it increments to fetch the next instruction. Next one is the memory address register or DMAR. So DMAR holds the address of the instruction or data to be fetched from the memory. Then the ROM or the memory. This is where the instructions and the data are stored. For example, the number 4, 12, 5 are stored here in specific addresses. Next one is the instruction register. So the IR temporarily holds the instruction fetched from memory so it can be decoded and executed. Next one is the control unit. So the control unit interprets the instruction in the IR and sends control signals to other parts of the circuit to execute it. Next one is the accumulator. So this one is the accumulator, the A. This is a register where intermediate results are stored during calculations. So accumulator A. Then the ALU or the arithmetic logic unit. So the ALU performs arithmetic operations like addition and the subtraction. Next one is the output register. So the result of the calculation is transferred here to be displayed. And the clocks. The clock synchronizes all operations in the circuits, ensuring that instructions are executed step by step. So for the program overview, so as you can see here, now let's discuss the program that calculates the 4 plus 12 minus 5. So the instruction register. So the LDAH or deload the value 4 from memory address AH into the accumulator. So the LDAH, so this one, it will load the value for the AH into the accumulator. The next one is the add 9H. This so add 9H, it will load the add 12 from address 9H into A. So 1 1 means na add. So you can see here. Then subtract is 2. So it will say 1 9 since it will add the 9H to the accumulator. So 4 plus 12 will be 16. The next one is the 2 which is subtracts, then the A which is AH which is 5. It will subtract the value 5 from the memory address AH. Then the out will display the result and halt will stop the program. So let's take a look at the ROM table again. So 00H, 0001 will load the AH, load 4 from address AH into A. 01H or the add 9H will add the 12 from address 9H into A or the accumulator. And 02H will subtract the AH, subtract 5 from address AH from the accumulator. 03H will output the result, then the 04H will halt the program, then 0AH, 8H is the data for the load instruction, the 09H is the data 12 and the data for the add instruction, the 0AH is the 5 or the data for the subtraction instruction for the subtraction. Then let's walk through the execution of the program step by step. So as you can see here, the PC starts at address 00H. Then the MAR will fetch the address. The ROM will output the instruction. So let's try to load the value 4 into the accumulator. Click, 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 click. So you can see now the 4 into the accumulator. It says 4 here. The next one is the PC will increment to 01H. Then let's try to add the ALU or the arithmetic logic unit will add the 12 address 9H to the accumulator. So let's click it again. 1, 2, 3, 4. Then you can see here the number 12. It will add it to the accumulator. So this will be now 16. So as you can see here, it's now 16. Then let's try to subtract the data from the accumulator. So the PC will increment to 0 to H. So the ALU will now subtract the 5 from address AH from the accumulator. So let's click it again. So 16. This shows the 16 minus 5 is 11. So 2A is 11. So let's click it. Then you can see the 5. It will send it to the accumulator to subtract. So now you can see the 11. So now let's click it again to show the output here. So as you can see, the 11 is now showing in the clock. The next one is that we will halt the program. The program will implement into the 4H. Let's halt the program. So now the program is halted. So we can reset it again through the use of this button. So let's now visualize the data flow. So the program counter fetches the next instruction. The memory address register fetches the address of data or instructions. Then the accumulator holds the intermediate results. Then the arithmetic logic unit performs the calculation. Then the output register displays the final result, which is 11. So with this program, the SAP-1 successfully calculates 4 plus 12 minus 5, then the final result is 11, is displayed in the output register. This program demonstrates the working of a basic computer with step-by-step instruction, the fetching, decoding, and execution. So now let's try to enable the clock here. So you can see the whole program running on its own. So first one is that it will load the 4 to the accumulator, then it will add the 12 to the accumulator, and it will subtract the 5 to the accumulator, which is 11, then show the display here. So as you can see now, then it will help the program. So that's the SAP one, or the simple as possible one. Thank you.